Welcome to a small overview of Venly's Gaming Solution Toolkit. So let's get started and check out what Venly has to offer. So Venly is a blockchain service provider, and Venly offers a range of products, of which some are APIs that you can use to interact with our services. One of them, for instance, is the wallet API that allows you to create wallets, manage wallets, also transfer funds from a wallet to another wallet. Also execute contracts, smart contracts, read from smart contracts. So all that stuff is encapsulated in the wallet API. You also have a market API that enables you as a studio or a developer to create your own white labeled marketplace. That means that you can have an in-game marketplace which features like purchasing offers, also starting an auction as a user. So it's a simple API that allows you to create simple marketplaces for your game. Then also some NFT tools. So Venly has its own smart contract, and with the NFT tools API or the NFT API, you can create instances of that smart contract that we have. You can also create tokens for that contract and also mint tokens on the fly using the NFT API. And there's also like a wallet widget. This is used more on the web. So that gives you the ability to have users log in into their Venly wallet account. But this is used on the websites. So we also have a gaming toolkit, of course, and the gaming toolkit basically exposes all those APIs that we have. So we have the wallet API, the market API, and the NFT API. And the gaming toolkit that we currently have for Unity and Unreal makes it very easy as a developer to plug in like a Web3 layer into your game. So we're blockchain agnostic, so that means you can leverage from all the blockchains that we support. And we are also trying to be backend agnostic. That means for certain things that you want to do with the API, you want to execute those endpoints, those calls on a secure environment. So that would be a backend. So in order to use the Venly Gaming Toolkit, you will definitely need a backend. And it's with that in mind that the actual SDK is built. So it acts as a bridge between your front end, which would be your game running on whatever platform, made in Unity or on Unreal. And you have access to everything we have to offer directly from the front end, but it's automatically going to bridge that call to your backend. So we have modules that you use on the game side, on the front end side. And we also have modules that you can use on your backend. And next to that, we also have some built-in support for live op services like Playfab and Beamable. So our SDK is automatically gonna have some functionality in there that will directly interact with built-in live op services like Playfab or Beamable. So now if you want to get started, if you go to developers here on the website, Gaming Toolkit, this will navigate you to our documentation of the Gaming Toolkit. And this will give you an overview of what the Gaming Toolkit, this is the one for Unity, currently has to offer. So at first you can see that we have a function reference here. These are basically the API functions that we support with this SDK. So we have the wallet API here, NFT API, market API, and these are kind of all the features that are currently in the current version of the SDK. So like creating a wallet, this then would be the function call that you need to execute on your front or your backend to create a new wallet. And you can also see what type of data that you need to provides in order to successfully make, in this case, create a wallet request. And yeah, we have this function reference for every API that we have, so you can already take a look at what we have to offer in terms of functionality. So this is the installation guide for the Unity package. You can see that we have a link here to a GitHub repository, and this is where the package is hosted. And it's as simple as opening up the packaging manager from Unity, copy pasting this link into the package manager, and let the package manager pull the package in. First of all, I need to copy this link. Then I can go to my Unity instance here, go to the package manager, and here you can select this add icon and select the add package from a Git URL. Now you can paste that URL in here and just click add. So now it's going to install the package. All right, so you can see that the package is currently installed. The Unity plugin also comes with a sample scene, so you can also immediately import the samples like that. Okay, so if you now navigate to the window menu item, there should be a Venly tab right here, and that should give you access to the SDK manager. So this is the SDK manager. It will show you some useful links, the version of the SDK, the option to check for updates. It will automatically update if there is a new version. And then here we have the settings. So it all starts with inputting your client ID, client secrets, and selecting whether you're working on staging, sandbox, or production. Let me use my personal client ID right now. Okay, so we're logged into the editor. So just to be sure, this client ID and secret is only used inside the Unity editor. So there's no way to create a build with these two parameters, your ID or your secret, exposed in a client build. That's not how it should work. You should only have your ID or secret exposed somewhere on your backend. So these parameters right here, this data, never leaves the editor. You can't even make a build with this information in it. It's merely used to use the SDK in the developer mode. So here you can see after logging in, this is our ID. This is the environment we're currently in. This is all the realms that we have access to. So we have access to the wallet, NFT, and the market API. And here you can also select the mode in which the SDK will run. So we have developer mode, dev mode. That means you don't need a backend to test and experiment with the SDK. You can just call the endpoints from the editor directly. It's something that you don't want to do or have once you have a release build. In that scenario, you really want a backend. So just for prototyping, experimenting, dev mode is perfect. You don't need to set up a backend or anything, and you can still use the entirety of the functionality of the SDK. There's also the option for Playfab. That means if you have Playfab SDK in here and you're using Playfab as a backend, you can automatically set it up so that it kind of finds the roads it needs to take to communicate with the backend. We have the same for Beamable right here. And you can also set up your own custom backend. So if you don't use Playfab or Beamable, and you have your own custom implementation, you can extend the SDK to make it communicate with your own custom implementation. So for now, let's leave it on developer mode, and let's go over some of the samples right here. So if you go to the samples, these are the samples that come with the package. There's one scene here, the API Explorer scene, which will show you this screen. So this is just a small sample. If you run it, you'll see that it gives you the option to check out some of the functionalities of the various APIs that we have to offer. So this is like the wallet API. Here you can see how to query the wallets. These are all the wallets that are connected with my client ID, for instance. This one. So now it's retrieving all the information. You can see the address here, the description, identifier, the balance, the native balance. It's a Polygon wallet in this case. You can see the ERC20 tokens. You can also check the details on them. You can transfer it from here. Every wallet has its own PIN code. So if you want to transfer, you have to give the PIN code of that wallet with the request. Here you can say to what target address you want to send it. And it's the same for ERC1155 and ERC721 tokens. So you can also create a new wallet in samples. Just select your blockchain, give it an identifier description, give it a PIN code, make it recoverable or not, and then you can create it. Transferring tokens is also showcased in here. NFT API, here you can see the contracts that you have in your account and also the token types that you have defined for the contracts. And if you have a token type, you can then also mint a token, multiple if you want. You can batch mint and send them to a certain wallet address. The market API, here you can view all the users that are currently part of your client ID. So the market API works independently from the wallet API, and that means that you can use our wallet solution, our marketplace solution, without having to use our market API. It works with a system of sub-users. So you would create a sub-user that acts on your marketplace. And a sub-user has a certain balance expressed in USDC. You can have multiple deposit addresses for multiple chains so that you can deposit funds on a account. And then you can also check out the current offers. So there are public offers that are part of our public marketplace, but you can also have like a private marketplace. So a marketplace that only works within your game or your realm. I don't have any offers on my own private marketplace at the moment. But here you can see there are different types of offers. There are sale offers. There are also auction offers. Okay, this is an auction, for instance. You can see all the bids that happened on here. It will close 8 December in this. Oh, it's already closed. And here you can just bid on it. And if you have the highest bid, you will get it. So it's normal marketplace functionality. So this is the samples that kind of showcase everything that is possible with it. The cool thing about this is every view that you see here. So for instance, they create a wallet view. If you want to know how it works code-wise, if you want to know how to implement or use this function, you can check out the code. So every screen view that you have right here will be in its own separate script. So this is the API Explorer. Inside View Controller's Wallet API, create Wallet View Controller. If you double click it, you'll see the exact code that was used to execute this call in this case. So the only thing that we need, and I also showed you that on the documentation page, is this create Venly or the create wallet function from the wallet API. Just give it some parameters. I also showed that in the documentation, the chain description, identifier, PIN code, what type of wallet do you want, and then you can just execute it. So this is going to create a wallet and notify you if it succeeded or failed. This is kind of in a nutshell how the API or the SDK works. Let's also look at a scenario in which we use a backend. So you can hook up your own custom provider. It's just a matter of setting up the communication channel between the front and the backend. But we have support for some, or built-in support for some live op services like Playfab or Beamable. So inside the documentation, you'll find more information on how to set it up. So how to set up Playfab, what is required. So for Playfab, you will need to create a cloud function. And Beamable is another live op service. And here you can also find all the information to set it up And for Beamable, we will have to set up a microservice. The cool thing about Beamable is that everything can be done from within Unity, so you don't need to set up external projects like you would have to do with Playfab. With Playfab, you need to create a separate project for your Azure function and also deploy that to the cloud. With Beamable, everything is like nicely incorporated through Beamable's Unity SDK, for instance, to pipeline everything and execute everything directly from within the Unity editor. So let's head over to another Unity project, which already has everything set up for Beamable. So this project has the Beamable SDK installed. You can see that we have a microservice here set up. This is actually the server-side code, which is now running locally on my device, but I can also easily deploy this and have it running on the cloud. And here is the SDK manager. You can see it's set to a Beamable, and there is some information that we need, like the name of the microservice. So you can already see it's the Venly provider service here, and the entry function for the calls that we make, which is called execute. Let's have a look at that microservice. So this is now the microservice code. This is everything that you need to set up to have like a backend connection, in this case for Beamable. So we have built-in support for Beamable. In this case, we created a Venly microservice if you are using Beamable. This is the function that is execute. And we have a simple function, which is part of the Venly microservice class, to handle the incoming requests and also return a appropriate result. Here you can also set up your endpoint guard. So here you can deny certain endpoints, allow certain endpoints, just to keep everything safe and only make sure that users only have, or players only have, access to the resources or the endpoints that they actually use or need, and can't do anything harmful. So this is set up, it's currently running. The details here are properly set up. So when I now play it, it's the exact same sample I just showed you. When I play it, you'll see that it'll start off from another screen. So now we're making use of the identity service of this live service, and we can create a user or login. So let's create a user. Let's create one I haven't created before. Give the password and also give it a PIN code. This is the PIN code required for certain actions. If you want to do something with the wallet, like transfer funds from the wallet to another wallet, this is the PIN code that will be required to execute that request. So now it's creating the user on the backend, which is Beamable, and will automatically create a wallet for that user and link that wallet ID to the user internally in the Beamable backend. You also have the option to create a market user if you want. So if you are also using the Marketplace API, you can also create a market user or a sub-user for this Beamable user. I already have like a wallet. You'll see it's empty, so I don't have any magic because it's freshly created. But basically anything that you can do with the API, you can now do with this wallet, which is created specifically for this Beamable user. And all the endpoints and code is also executed on a backend. So I can safely export or publish this project right here. And all the sensitive information is stored on the backend. Nothing is exposed in my front end application. And I still have the option to kind of use the functionalities from within the front end. But because of the way the SDK is built, it automatically always bridge to a backend that you configured. The last thing I want to go over is our Venly Dash sample game. So again, if you go to the documentation, you'll have a link here to our Venly Dash sample. So this is a small game project that we created. It's basically based on Venly's Trash Dash game. So they have an endless runner. Unity created this endless runner application, and it's free to use. So you can use the project, the assets, and just play around with it. So it's a original Web2 game. So it has a login screen. What we wanted to do is we wanted to create a Web3-ified version of this already existing Web2 game. If you want to check out the demo, you can just click this link right here. Okay, so this is the little game. Let me just log in here. It's a simple game that has the Web3 wallet attached to it. There are some NFTs in the wallet, and based on the NFTs that you have in this wallet, you can unlock certain aesthetics. So based on the NFT that you select right here, you can change the accessories of this character. There are also different characters, and there's a store where you can buy NFTs if you want for these coins, these Venly coins that you need to collect by playing the game. And the game is just a simple, endless runner with the option to collect coins. And with these coins, you can then buy these NFTs, which are minted on the fly. And using the Venly API, we can query the wallet of this user, check out which NFTs there are inside this wallet, and then also unlock these features inside the game. So back to the GitHub page. So all the code, all the source code for this project is available here on this GitHub repository, of which the link you can find in the documentation. This project uses Playfab, and you can check out all the scripts that we used. So what functions that we called on the Venly API, and also what function that we used for Playfab. And because we're using Playfab in this example, there's also an additional project which hosts the cloud function, so the Azure function for Playfab. And this is all that it contains. So this is an Azure function, similar to the microservice of Beamable that I just showed you. So we're using like a companion module right here, specifically built for Azure functions, which you can also find on the documentation. And this is the entry of that function, and you can see that everything is handled by the SDK. So we just give it the request, and we send or return a appropriate response. So this is a great example of a working game, which was originally a Web2 game, but we Web3ified it. And this is also one of the strengths of our SDK. You don't need to add additional user flows into your user onboarding to enable Web3. You can just keep everything in the background and just have the users interact with it whenever they want. Feel free to get in touch in case you have any other questions or remarks, or there are certain features that we don't currently support that you want to see supported. Just drop us a line and we'll see what we can do.